A relative motion problem. There is a pickup truck traveling to the right with a speed of 10 meters per second. There is a person in the truck throwing a baseball at an angle with a speed 40 meters per second at an angle of 60 degrees with respect to the horizontal. The question is, what is the velocity of the ball as measured by an observer on the sidewalk? Once again, there is a pickup truck moving to the right with a speed of 10 meters per second. A person in the truck is throwing a baseball with a speed of 40 meters per second at an angle of 60 degrees with respect to the horizontal. What will be the speed of the ball according to this person? What will this person measure? We recall our equation. VAC is equal to VAB plus VBC, which reads like as velocity of A with respect to C is velocity of A with respect to B plus velocity of B with respect to C. In this problem, let's label the truck as T. Let's label the earth as E. And let's label the baseball as B. So this equation, in our case, can be rewritten as what is the velocity of the ball with respect to the earth? If we write this equation using our notation, we have velocity of the ball with respect to earth is equal to the velocity of the ball with respect to the truck plus velocity of the truck with respect to the earth. What is the velocity of the ball with respect to the truck? We have this vector of magnitude 40 meters per second, and we have this angle of 60 degrees. We are decomposing the vector along the x and the y direction. Simple trigonometry shows us that this side of the triangle will be 40 times cosine 60, while this side of the triangle will be 40 times sine 60. So 40 times cosine 60 is equal to 20, while 40 times sine 60 is equal to 34.6. So the velocity of the ball with respect to the truck can be rewritten as negative 20 I hat plus 34.6 j hat. Negative because this is to the left, positive because this is up. On the other hand, the velocity of the truck with respect to the Earth is simply 10 I hat. It is because the truck is moving to the right. So when we come back to this equation, we have velocity of the ball with respect to the Earth is velocity of the ball with respect to the truck, so minus 20 I hat plus 34.6 j hat, plus velocity of the truck with respect to the Earth plus 10 I hat. We know how to add vectors. Minus 20 plus 10 will become minus 10 I hat, and 34.6 j hat is left untouched. So the velocity of the ball with respect to the Earth is negative 10 I hat plus 34.6 j hat. Now I can draw these vectors. Negative 10 I hat means I have a vector of magnitude 10 to the left, and 34.6 means I have a vector of magnitude 34.6 up, 34.6 j hat. I add these two vectors. So this vector here will be square root of 10 squared plus 34.6 squared, which is equal to 34.6 squared plus 100 and square root of that. I get about 36 meters per second. And I can go even further and find this angle. Tangent of that angle is 34.6 divided by 10, opposite over adjacent, or 3.46, which is equal to about 74 degrees. Theta is about alpha is about 74 degrees.